Good day everyone. In this video on environmental chemistry, we will be talking about water. This is aligned with our learning guides 2.3 to 2.7. The overall outline of our lecture is here in this slide. First, we will be reviewing what you already know, global distribution of water as well as the water cycle. Next, we will be looking at parameters of water quality. These will serve as the basis of whether water is safe for its variety of uses. Then, lastly, we will be talking about water pollution and water treatment. This lecture will be divided in 3 parts. This video is part 1, so we will only be talking about the highlighted topics here. So, let's now jump right into the lecture. Water is very essential in life. Water is life, ika nga. And sure enough, around 70% of the world is water. But to put things in perspective, let's go to the numbers. More than 96% is saline water, which is good news for aquatic organisms, plants, and animals that live in the sea. However, only 2.5% is fresh water, and hindi pa lahat ng yan ay available for human consumption. Lakes, rivers, and groundwater reservoir are the usual sources of drinking water. Of course, necessary processes for purification ang kailangan pagdaanan before we can drink it. So, you see, water might seem a commodity that is easily available for us, but it's not true for everybody in the world. So, this is something that you might want to keep in mind as we go through this topic. Okay, now, how does water, quote unquote, travel all around the globe? Okay, well, for sure, narinig nyo na ang water cycle. This is the Earth's natural purification and recycling system. Okay, water goes through the major processes of evaporation, transpiration, condensation, and precipitation. You will also see that water is stored in the atmosphere, on the surface of the Earth, and in the ground. So we just breezed through the water distribution and water cycle, but you can read more about these in our learning guides. But for now, we will proceed to the more exciting part. We are going to look at water quality measurements, or what we also call water quality parameters. I mostly based this in another video. The link is shown in this slide. We will be discussing the water quality parameters according to 3 types: aesthetic parameters, in situ parameters, and laboratory measurements. Aesthetic parameters. These are measurements of water quality that you can see or smell or even taste. You don't need instruments for these types of measurements, just your senses. When we drink our water, or when we are swimming in a body of water, for example, we can readily observe its characteristics. And even though these are kind of subjective, these are still important because these can indicate presence of toxins or contamination. Okay, first let's go to odor. Some of the smells encountered in the field and what they indicate are shown in the table. Rotten egg smell could be a sign of raw sewage or decomposing organic matter or a lack of oxygen. A chlorine smell can indicate a sewage plant discharge or a swimming pool overflow or an industrial discharge. A sharp, pungent odor may indicate chemicals or pesticides. A musty odor can indicate the presence of raw or partially treated sewage or livestock waste. A rancid or sour odor may be a sign of a garbage or some kind of dead organism nearby. Gasoline or petroleum type of smell can be a sign of industrial discharge, illegal dumping of waste, or wastewater. And lastly, a sweet, fruity smell can be commercial wash water, or wastewater. Second, the color of the water can tell you a lot about the source of water as well. This chart shows some of the common colors encountered in the field and what they may indicate. A brown color can be suspended sediments, construction runoff, agriculture, or soil erosion. A green or yellow or brown or blue color can indicate an algal bloom or fertilizer runoff or perhaps vehicle wash water. A white color may indicate paint or lime, milk, grease, concrete, or swimming pool filter backwash. A gray color can indicate domestic or commercial wastewater, like laundry water or bathtubs or bathroom sinks. You can think of gray water as relatively easy to reuse or recycle. A black or dark gray color would indicate a raw sewage discharge or other oxygen-demanding wastes, and the rotten egg odor may be present with this as well. If you get some strong blues, reds, purples, or blacks, that can indicate fabric dyes or paints that may be inks from paper or cardboard manufacturers. And an orange color can indicate a leach from iron deposits. Visual observation at the water surface can also give us some useful information. In the first image, a natural sheen can be seen in the surface. These colorful bands will crack and disperse when disturbed. They are caused by minerals or organic decay, not exactly an indicator of pollution. The top middle image is natural foam. Bubbles are located at a water drop-off that breaks up quickly and contain no odor. This is caused by water turbulence and organic decay. On the top right, we see iron bacteria. The bacteria combine oxygen with dissolved iron to form a rust-colored slime in the water. This is a natural occurrence and not man-made pollution. On the bottom left, we see soap suds. These are bubbles with iridescent colors that have a fragrance. This may be caused by detergent gray water or sewage, and that's a sign of pollution. An oil sheen will have color bands that swirl and stay together when disturbed. This would be caused by pollution from petroleum products. And lastly, on the bottom right side, you see quote-unquote sewage fungus. Yung itsura lang niya yung mukhang fungus, but this is actually caused by bacteria associated with sewage polluted water. Okay, now tapos na tayo sa aesthetic parameters. Let's go to in situ, or literally meaning on-site, field measurements of water quality. These are parameters na minimeasure sa mismong site where you get your water sample. So, real-time dapat kunin yung measurement for the data. So, this is where portable water monitoring equipment come in. First, temperature. Temperature is an important field measurement because the plants and animals that live in the water are dependent upon certain temperature range for their optimal health. Variations above or below that range affect the life processes of these organisms. The best temperatures for fish, for example, depends on the fish species. Some species prefer colder waters, whereas others prefer warmer waters. If temperatures are outside the optimal range for a prolonged period of time, organisms will become stressed and could die. This might have direct impacts on the ecosystem. Also, warmer water cannot hold as much dissolved oxygen. So, lower dissolved oxygen amounts mean aquatic plants and animals will not thrive. Another common field measurement is pH. pH is a measurement of the concentration of hydrogen ions in a solution. Measuring pH is important because it determines whether water is acidic or basic. The scale ranges from 0 to 14, with 7 being considered neutral, and if the pH is above 7, it's basic. If the pH is below 7, it's acidic. Aquatic organisms prefer a pH of around 6.5 to 8, but it depends on the species as well. When pH is outside of that range, mas-stress ulit yung organisms and can reduce the reproductive rates. Also, solutions that are too acidic or too basic may change the solubility of different materials in streams. For example, kapag acidic yung water, mas madaling makadissolve ng rocks, and this can introduce heavy metals such as lead in the water. Okay, next, conductivity. Conductivity measures electrical current. In the table, you can see some of the more common cations and anions that contribute to conductivity, like calcium carbonate, also known as limestone. And so, when water runs over limestone, over time, calcium and carbonate ions will dissolve and contribute to a higher conductivity. There is an optimal range for conductivity that can vary depending on the location. But if the conductivity is elevated because of too much salts in the streams or other types of pollution, it can impact aquatic life. Too much salt can lead to dehydration or even death for aquatic organisms, especially if they are freshwater fish. Conductivity, by the way, is measured in microsiemens. Another common field parameter is dissolved oxygen. Most aquatic organisms obtain the oxygen they need to survive from the oxygen dissolved in the water. Oxygen enters the water from the atmosphere and from the groundwater, as well as from the photosynthesis of aquatic plants. The dissolved oxygen concentration can vary based on many factors. Cold water can hold more dissolved oxygen than warm water. This is one of the reasons why global warming is harmful to our aquatic life. Reduced yung dissolved oxygen at higher temperatures. Running water, such as that of a river, dissolves more oxygen than the still water of a pond or lake. Aeration occurs because mas frequent ang interaction ng water at ng atmosphere. Kaya important yung aerator sa aquariums, right? That is to increase dissolved oxygen. So the stronger currents mean higher ang dissolved oxygen. Also, loss of dissolved oxygen will occur if too many bacteria in the water are present, because of course these bacteria also consume oxygen. As organic matter decays sa water, mas marami ang bacteria, and this causes the depletion of dissolved oxygen. This is especially a problem in a stagnant body of water, such as a lake with a large amount of decomposing material in warm temperature. In the summer, mas maraming report of fish kills sa lakes due to lack of dissolved oxygen. Okay, last, turbidity. Turbidity is a field parameter used to estimate the amount of suspended particles by the amount of light scattered by the water. Kung maraming suspended particles, either they are algae or soil particles, this causes greater scattering of light, so less light penetrates to the plants or organisms below. High turbidity will appear cloudy or muddy, while low turbidity appears clear. Turbidity can be measured by visual observation, So, i-estimate lang kung turbid or clear. We can also use a Secchi disc. Secchi disc is a black and white disc tied to a rope, and this is lowered down into the water until you can no longer see the black and white. And then you record that depth. Another device is a turbidimeter, which can be used to record turbidity units. So in the image shown, itong model ng turbidimeter, para siyang maliit na UVV spectrophotometer na maglalagay ka ng vial containing your water sample. Then it will measure the amount of light that passes through and gives you the turbidity measurement. Okay, so that is all for this video. Just a review. We discussed water distribution and water cycle. And we also discussed partially the water quality measurements or parameters. In particular, yung aesthetic parameters such as odor, color, visual indicators, and yung in situ parameters such as temperature, pH, conductivity, dissolved oxygen, and turbidity. So, in part 2, we will be discussing the laboratory measurements. So that is all for this video. Thank you for listening.